Hey guys, check this out. This is the QAV-PRO Vier from Lumenier and cinequads. It's a 4-inch cinewhoop that has something to offer both video professionals and FPV hobbyists because it's designed to carry a lightweight cinema camera, but you can always use a full GoPro and a heavy 6S battery, and you can set this quad up as a no compromises freestyle ripper or as an efficient cinematic cruiser, depending on which motors and props you use. We're going to talk about that in just a second. But first, I need to point out, this is not a bind and fly. You do need to build up this frame yourself, but Lumenier has a bundle with all of the recommended parts that I'll link to in the video description below. Full disclosure, Lumenier did send me the frame and the antennas for this build, and T-Motor sent me a set of these Pacer V3 motors to try out. So what are the advantages of a bigger, heavier, and more expensive cinewhoop like this, and do those advantages justify the cost? That's what we're going to talk about in this video. If you're new here, welcome. My name is Jason. Please do subscribe because I want you here for future videos. Now this video has a lot of information, so I'm going to break it up into bite-sized chapters. Feel free to check out the video description below for the timestamps, and you can jump around as you need to. All right, let's get into it. The frame uses the classic two-plate cinewhoop design, similar to what we see on other QAV-PRO cinewhoops, where the components are laid out in the middle to give you the best possible center of gravity. This is a pusher quad, and there's nothing obstructing the airflow beneath. This frame is designed to be able to carry lightweight cinema cameras, and it does have built-in mounting for the Blackmagic naked pocket cinema camera with mounting holes here, here, and here, which are 124 millimeters by 90 millimeters. That mounting pattern will also work with Lumenier's QAV-PRO Cinema Camera Mount, which will allow you to mount other lightweight cinema cameras. What's really appealing about a 4-inch cinewhoop like this is that even though it's a cinematic quad designed to carry cameras, if you put the right motors and props on it, it's capable of ripping around and even doing some freestyle. Before we dive into my build, I'm going to try to make a case for the 4-inch cinewhoop. If you're coming from cinelifters, this quad may seem small, but if you're coming from a traditional cinewhoop, it's huge. Here it is next to the QAV-PRO Nano. Now this is a 2-inch cinewhoop designed around the DJI O3 air unit. Smaller quads like this are sort of like the cinewhoop for the masses because they're cheaper, less noisy, and better suited for tight spaces indoors and around people. But if you want to be able to carry a full GoPro, you really need to step up to a larger cinewhoop, something like this GEP-RC Cinelog 35. I like to fly my Cinelog 35 with a GoPro Bones. It will handle a full GoPro and a heavy battery, but when it's loaded with so much weight, it flies like a cinewhoop. It does okay with slow cinematic shots, but if you try to fly fast, it makes a ton of noise. There's prop wash you can't tune out, and it's more like a moving van than a sports car, if that makes sense. If you want to be able to carry heavier payloads like a lightweight cinema camera or a full-size GoPro or some other heavy action camera and a huge battery, the QAV-PRO Vier will do that with the power and performance to fly more like a freestyle drone, depending on the motors and props you choose, or it'll just be able to fight the wind better and be able to fly well in different scenarios, with the benefits of a safe and stable prop-protected platform. Let's put it this way. A micro cinewhoop is cheap and efficient, like a Toyota Prius. The QAV-PRO Vier is a purpose-built vehicle like a Humvee. It's not lightweight or economical, but there are times when you need a heavy vehicle to get the job done. This frame weighs in at 220 grams, and my completed build weighs in at a beefy 514 grams. That does include these huge 2207 motors that I'll tell you about in just a second, a full-size GPS unit, 2 antennas with their SMA extensions, a diversity receiver with antennas in the front and the back that I'll show you in just a second here, a lost model buzzer back here, a GoPro mount with its M5 screw, and of course 2 battery straps. With a 1300 milliamp 6S battery, it weighs 747 grams. With a 1500 milliamp 6S battery, it weighs 778 grams. With an 1800 milliamp 6S battery, it weighs in at 827.5 grams. And with a GoPro 13, with an ND filter and a battery, it weighs in at 985 grams. This is a pretty heavy setup at nearly a kilogram, but remember that this quad is designed to carry lightweight cinema cameras that weigh a lot more than a GoPro, so this is how I'm going to test out this quad. The carbon on this frame is very high quality. It has chamfered edges, and the holes where the hardware goes have been milled out so that when the quad is assembled, all of the hardware sits flush and it looks and feels very premium. Although for me, it's an aesthetic choice to mill out all of the hardware holes, and I do wonder if it sacrifices durability by removing so much of the carbon. Another thing is that it can be a real problem to source new hardware if you lose some of those screws, or if you need some motor mounting screws which are slightly longer or slightly shorter. The top plate and bottom plate are 2.5 millimeters thick, and the side plate is 2 millimeters thick. You do have the option of building up this quad without the side plates, and there are M3 mounting holes in the tabs where the side plates go, so you could replace the side plates with standoffs in case you needed to fit in some oversized electronics. The antennas are designed to be mounted to both sides of the quad, and I really like this design because it seems like it'll provide better reception as opposed to having them hang off the back. This frame was designed for the DJI O3, and I did my build before the O4 came out, but I know a lot of you guys are going to be wondering if you can install a DJI O4 or another VTX in this frame. Installing an O4 air unit is not a problem because it has standard 25 by 25 mounting holes, but you wouldn't be able to use the included heat sinks, which are designed specifically for the O3. The O4 camera is also 20 millimeters wide, so it is compatible with this camera mount, but since the spacing of the mounting screws are different on the O4, you would only be able to use 2 of the 4 mounting holes. Lumenier has told me that they do plan to release an update to accommodate the DJI O4, so by the time you're watching this, this frame might already have been updated for the O4. I don't have an O4 yet because I live in South America where the mail is super slow, but as soon as I get my hands on one, I'll test fit it and I'll let you guys know in a pinned comment below. The frame kit does come with these 2 pigtails to allow you to connect your antennas to the DJI O3 air unit, but notice that they're using SMA connectors. I usually use RP SMA antennas on my digital quads, which is a habit I picked up from the original DJI goggles. If you do prefer RP SMA antennas, GetFPV has these pigtails with RP SMA connectors available. I would highly recommend picking up some of these AX2 left-hand circular polarized SMA antennas because they perform well and they're just the right height. They're tall enough to peek over the battery, but not so tall that they're going to hit anything if you fly through a gap. There are aluminum standoffs throughout the frame, and the front of the quad uses an aluminum camera cage, which also acts as a front standoff. The mount for the DJI O3 camera uses 2 carbon plates mounted to aluminum standoffs and isolates the camera from vibrations with rubber grommets. You do get a pair of aluminum heat sinks for your DJI O3 air unit, and there's plenty of space to mount it up front or in the rear, but if you go for the rear mounting option, you will need a longer camera cable. The stock cable that comes with the DJI O3 is not long enough to reach back there. I mounted my air unit up front and used a zip tie to keep the extra camera cable out of the props. A problem I had with my build is that these side plates make it difficult to access the USB port and basically impossible to take out the SD card. You can access the USB slot in order to offload your footage, but only with a specialized cable. Here's the cable that came with my QAV-PRO Nano, and as you can see, it's much thinner than a standard data cable, and it just barely clears the carbon of the side plate. Another option would be to mount a right angle USB extension like this one from Diatone. So don't forget to put a good SD card into your DJI O3 when you're doing your build, because it's basically going to live there. I have to point out that other cinewhoops solve this problem by including USB extensions into their designs, and Lumenier really missed an opportunity to do that here, or at least to include this special USB-C cable like they did with the Nano version. We do get a molded plastic GoPro mount, which slots right into the carbon and locks in place with a screw. This is the same mount that we get with the QAV S2 JohnnyFPV frame that you guys have seen on the channel before. It looks good and it works well, but you do have to be careful not to over tighten your GoPro or it'll crack. Ask me how I know that. I would really like to have a TPU GoPro mount available, whether as an STL file I could print or as an optional upgrade I could buy, because TPU does have advantages over molded plastic in some cases. With TPU, you can really lock down your camera and it won't crack or break under compression like plastic can. Then again, the mounting screws that you use to mount a TPU mount can pull through in a crash, so there are advantages and disadvantages to both systems. I think the pilot should be able to decide based on their needs. Hopefully we'll see some STL files soon for this frame. The kit comes with these nylon landing feet, but to be honest, they don't really do much, and I really prefer these foam landing feet that you can pick up at Get FPV. They're much more forgiving and raise the quad up a little bit more for takeoff and landing. Without them, you'll go through props super fast, because on a pusher style cinewhoop like this, where the props sit under the motors, there's a constant risk of the props making contact with uneven ground or grass when you land. This is another point where some TPU parts, or at least some STL files, would have been nice, but I prefer these foam landing feet anyway. To mount our electronics, we get 3 sets of 25 by 25 millimeter mounting holes in the front, the rear, and the back. We get a single set of 20 by 20 millimeter mounting holes, and there's no 30 by 30 millimeter mounting. More on that later. I think this frame is extremely solid. It's lightweight for its size, yet there's no flex at all, and you have loads of space and flexibility to build it up however you want. Alright guys, now let's talk about choosing components for the QAV-PRO Vier, and I'll give you a close look at my build. The designers have made some very interesting choices when it comes to motors and props. They're recommending T-Motor F60 Pro or Pacer 2207 2550 kV motors for this 6S quad. When I saw that motor recommendation, my first impression was that kV was way too high for 6S, and it's a recipe for hot motors and short flight times. 2207 is usually what we think of for a 5-inch racing or freestyle drone, and that kV is usually intended for 4S. For 6S voltage, we'd usually want something in the 1700 to 1900 kV range. The philosophy here is that a motor designed for a 5-inch prop like this one will be able to spin a smaller 4-inch prop at higher RPMs, resulting in more torque and lifting power for a cinewhoop designed to carry heavy loads. This is not a completely new idea, and similar combinations have been used before on the Shen Drone's Terraplane and the Catalyst Machine Works Whoopmaster, and most pilots that have flown those drones love the way they fly. In my experience, this combination is super fun to fly. It feels like an overpowered freestyle quad, yet I have the safety of prop protection and I can carry around my full GoPro 13 and a heavy battery like they're not even there. When I reviewed the Beta FPV Pavo 35, I loved the way it flew for the same reason. It used larger, higher kV motors, which were 2006 2400 kV on 6S, which made it fly so much better than a standard cinewhoop. So oversized, higher kV motors is not a new concept when it comes to pushing the boundaries of what a cinewhoop can do. With these 2550 kV motors on 6S, my QAV-PRO Vier hovers pretty low in the throttle range, and it'll take off like a rocket at higher throttle values. So I can confirm that with the recommended motors, this quad has power and thrust to spare, and carrying heavy payloads like a lightweight cinema camera or an oversized battery is not a problem. However, you should be aware that the recommended motors are designed to prioritize power and payload capacity over efficiency. Remember I said at the beginning that you can set this quad up as an overpowered ripper or an efficient cinematic cruiser. I think the iFlight 2205 2300 kV motors would be a very interesting choice if you want to strike a balance between efficiency and power. Now for props, Lumenier recommends these HQ 4x4x6, which are designed for cinewhoops, or the HQ 4x3x3, which are more of a multi-purpose 4-inch prop. 6-bladed props like this are going to be less noisy, and the sound is going to be more of a lower pitch hum than a high-pitched whine, and they're going to provide more thrust, but they're also less efficient and they'll give you shorter flight times. The 3-bladed props, on the other hand, are going to make more of a high-pitched sound, but they're going to be more efficient and give you longer flight times. One of my subscribers, Chris, recommended the Emax Scimitar 2.4 or 2.8 pitch 3-bladed props, which are more efficient and might do better with the insane RPMs we're going to see with this 2550 kV 6S motor combination. I am running the recommended 6-bladed cinewhoop props on these 2207 2550 kV motors because I wanted to build up my QAV-PRO Vier as close as possible to how the designers intended. Remember that this quad was designed with this power combination in order to have the lifting capacity to carry a cinema camera. It's a Humvee, not a Toyota Prius. In the bundle page, Lumenier pairs this quad with a T-Motor F7 all-in-one board, which has a 45 amp ESC. I really wanted to use full-size electronics because this build is designed for high kV motors on 6S, and I wanted to make sure my ESC would be able to supply the amps those motors would need. So I went with this T-Motor P60A ESC with an H743 flight controller. Now a 60 amp ESC is totally overkill on a 4-inch build, but some would argue that running 2550 kV motors on 6S is also overkill. Unfortunately, this massive 60 amp ESC won't fit in between the side plates because it has an oversized heatsink and solder pads. Even if I built up the quads without the side plates, there's no 30x30 mounting holes. Also, the mounting holes are M2, not M3, so this 4-inch cinewhoop frame really is designed for an all-in-one board or mini 20x20 electronics. I do have a few stacks just lying around waiting to go into builds, and so I test fit a few options for you guys. This Mamba Mark IV F740 all-in-one board with a 40 amp ESC fits great. I also test fit a Diatone 20x20 stack with a 40 amp ESC, and it also fit very nicely with plenty of room to route your motor wires. I ended up using an iFlight mini stack, and I chose this stack because it's the only one that I have access to with 20x20mm mounting holes and a beefy 55 amp ESC. These iFlight stacks do have an odd shape because they're designed to fit into iFlight frames, but it just happened to suit my needs for this frame perfectly. But if you want a very capable stack that you can be sure will fit this frame like a glove, I highly recommend going with that T-Motor F7 45 amp all-in-one board that Lumenier recommends on the bundle page. For my build, I prioritized getting the beefiest possible ESC that I could fit into this frame because I felt like running 2550 kV motors on 6S is asking a lot from smaller sized electronics. What do you guys think? Would my 40 amp all-in-one board or 40 amp mini stack have been enough for these 2207 2550 kV motors on 6S? I am using a GEP-RC 2.4 GHz Diversity ELRS receiver. The front antenna is mounted in the included Crossfire receiver holder, and the back antenna I have mounted on the back of the quad like this with VHB tape and zip ties. That should give me a nice solid connection no matter which way the drone is pointing. The receiver itself is mounted back here, again with VHB tape and zip ties. I'm also using a GEP-RC M10 GPS unit, which I have covered in clear heat shrink and mounted to the top plate with VHB tape and a zip tie. These GEP-RC GPS units are solid and they get satellites very quickly. I went with a full-size GPS because this is such a big, powerful quad that a few grams doesn't really matter. But in hindsight, I think a nano GPS unit would probably mount up to the narrow carbon plates a little more securely. This setup works fine, it's not going anywhere, and I get a fast and reliable GPS lock. I did install a buzzer back here with some built-in LEDs, and that'll help me find the quad if I go down in some tall grass or a forest or some bushes or something. Since this is a pusher style quad, cable management can be very difficult because you have to mount your motors to the top plate and you really have to mount your electronics to the bottom plate in order to be able to use the battery straps. When I built my QAV-PRO Nano, I was able to mount all the electronics to the top plate so that I could just separate the two plates whenever I want to work on the quad. And that was possible because of this unique battery strap design that came with the frame. But it wasn't really an option with the QAV-PRO Vier. I really had to plan out my cable management ahead of time, and I routed all of my cables and wired up all of my electronics before I soldered up the motors so they wouldn't be in the way. Usually I would mount and solder my motors first, then wire up all of my electronics, but in this case I had to do it the other way around. You do want to be very careful that none of your wires get pinched when you sandwich the side plates with the top and bottom plates. It's very easy to pinch a motor wire. Ask me how I know. I took my new build out to an open field to do the maiden flight, and flying this quad is a ton of fun. You really have to change the way you think of a cinewhoop because this quad doesn't fly like any cinewhoop I've flown before. I thought those 2207, 2550 kV motors were going to blow up or melt on 6S, but they handled the voltage just fine. They were warm, but not too hot when I landed. If you can't hold your fingers on a motor after landing without getting burned, your kV is too high. And I'm surprised how well these high kV 2207s handled 4-inch props on 6S voltage. I love the power and the way it flies. You can really rip it around if you want to, keeping in mind that my all-up weight with a GoPro 13 is near 1 kilogram. This is a filming rig, not a freestyle quad. The biggest difference I noticed between this 4-inch rig and a smaller cinewhoop is the authority I have to fight the wind. This was a super windy day where a lightweight quad would have had trouble holding a line without getting blown around. I got 6 minutes on a 1500 milliamp 6S battery and 7 minutes on an 1800 milliamp 6S battery. But that really depends on how you fly. Flying aggressively, you'll get shorter flights. But if you spend most of your time doing cinematic cruising, you get much longer flights. If you want longer flight times, you might consider more conservative props like the HQ 4x3x3s that Lumenier recommends. If you plan to fly a cinema camera, I think this aggressive power combination is just what you want. What do you guys think about this motor kV and prop combination on a 6S camera carrier like this? What combination would you go for, or would you go for something different? The good thing about a prop protected design like this is that you don't break props very often, so you might want to pick up a set of each to see which ones fit your needs better. Alright you guys, let's be honest. The FPV market is full of innovative and very capable cinewhoop designs. So why would you go with a larger, more powerful, and more expensive cinewhoop like this? For video professionals who need something reliable to carry expensive cameras that will perform well in challenging environments without posing the danger when flying in close proximity to people or expensive assets like cars, a quad like this is going to be a very appealing video production tool. For hobby FPV flyers like me, the QAV-PRO Vier offers a high-performance filming platform with the payload capacity to carry a full-size action camera and oversized batteries for longer flights and way better performance and authority than a traditional cinewhoop, while still offering prop protection so I can get in close proximity to my subject or maybe obstacles like buildings or tree branches to get some very interesting shots. Let me know what you guys think of the QAV-PRO Vier cinewhoop. Is a 4-inch cinewhoop right for you, or are you going to go with something smaller or something bigger? What motors and props would you choose in order to take full advantage of this design? Are you going to build a Prius or a Humvee? Let me know in the comments. I want to hear from you guys. All right, thanks a lot for watching. I'm really glad to have you here, and I'll see you in the next one.